Alright, and here we have another example where we have a couple of given quadrilaterals here, and it says that the quadrilaterals are similar with corresponding sides parallel. So we know that these two quadrilaterals are similar, meaning that this is just a larger version of this, and that we have a couple of parallel sides here. So what we can say here with a similarity statement is that quadrilateral DEFG is similar to JKLM. And once again, as with the previous example, it's very important in which order the vertices go. So if we say D is right here, and D corresponds to J. D is in the same position in this quadrilateral as J is in this quadrilateral. It's kind of that upper left-hand corner, but that's just kind of because they're oriented the same way. But D and J are in the same position. If you made this figure bigger, J would become D, or it would be in the same place as D. And then E, right down in the left here, E is in the same position as K. If we kind of put these two things on top of each other, K and E would kind of overlap. They're in the same position. And then F is in the same position as L. F corresponds to L. Those two are in the same position. And lastly, G corresponds to M. These two are in the same position. They are corresponding. So it's very important that when we say this or write this similarity statement that we do it in that particular order. So we say D, E, F, G. If we go in that order, we have to say J, K, L, M. That is a similarity statement there. And we have to find X and Y. And since we know these are similar, we know that the relationships between all the corresponding sides are also similar. So the only matching sides that we have here, or corresponding sides that we have, are 6 to 4. This side right here corresponds to this side. So we know the relationship is whatever 6 is to 4. So if we want to find X, one of the proportions we can set up is X to 8, and we're setting up X because we want to find X. So whatever X is to 8, because X corresponds to 8, whatever that relationship is the same as 6 to 4, because these things are similar and these two ratios should be equal. So we're going to set up a proportion, and a proportion is where we have equal fractions. So X to 8 is the same thing as 6 to 4. So like we did last time in 5-9, we are going to cross multiply. There's a couple ways you can go about solving this proportion. We know the relationship from 4 to 8. We can probably use that and figure out what X is going to be there. What I'm going to do is cross multiply. So I'm going to do 8 times 6. And whatever the value of 8 times 6 is, that value has to be the same as 4 times X. And from that I would get this equation. 4 times X has to equal 48. Once again, if you have two equal fractions, if you cross multiply, the products of that cross multiplication should be equal. That's all that we're doing here. So 4x equals 48, and if 4x equals 48, we divide both sides by 4, and we find that x equals 12. So the value of x is 12, which we were supposed to find. Now we have to find the value of y. And there are a couple of proportions we could set up for y, and we know that y corresponds to 15, so that is one of the ratios we will want to set up here. So we say that 12 to 8, I'm going to pick 12 and 8, the side that we just found. So 12 to 8, whatever the relationship is between 12 to 8, must also be the same as whatever 15 is to y. So whatever 12 to 8 is the same as 15 to y. And notice when I'm setting up this proportion, 12 and 15 both come from the larger quadrilateral, and 8 and y come from the smaller quadrilateral. So it's kind of important that we kind of say 12 to 8 is the same as 15 to y, where we have the same numbers from the respective quadrilaterals in both the numerator and the denominator. So 12 to 8 is the same as 15 to y, and now we're in kind of the same boat we were in with this proportion, where we can just cross multiply. 8 times 15, whatever that is, that has to be the same as 12 times y. So this is the resulting equation we get. 120 comes from doing 8 times 15. 8 times 15 is 120, and whatever that is has to be the same thing as 12 times y. So what I'm going to do here is divide both sides by 12, and you will find that y equals 10. So the value of y would be 10. Now we want to know what are the two possible ratios of similitude for the figures, and the reason there are two is because we can go from large to small or from small to large. So let's go large to small first. So large to small would be 15 to 10 because 15 corresponds to 10, or 12 to 8, 12 corresponds to 8, or 6 to 4, 6 corresponds to 4. And the difference between all of these fractions is nothing. Why is it nothing? Because these things are similar. If they weren't similar, then they wouldn't be the same. So we would reduce these. We can reduce these fractions. We can reduce 15 to 10, 12 to 8, 6 to 4. They're all the same thing. So if we take 6 to 4 and try to reduce that, that ratio of similitude is going to be 3 over 2, or 3 to 2. That is, 15 over 10 can reduce to 3 over 2. 12 over 8 can reduce to 3 over 2. And 6 over 4 can reduce to 3 over 2. So as a result of that, one of the possible ratios of similitude is 3 to 2. And that's if we go from large to small. The ratio of the large to the small is 3 to 2. You can do the same thing with the small to the large. We just take the reciprocal. We're just going to flip everything over. We're going to say 10 to 15 is whatever 8 is to 12 is whatever 4 is to 6. And similarly with all these fractions, they are all the same. And if we reduce them, we will get 2 to 3. The ratio of similitude going from small to large is 2 to 3.